The universe is a realm of spectacular discoveries that often leave us awestruck. Today, we delve into some of the cosmos' most incredible and colossal structures, objects that defy the imagination and reveal proportions far beyond what we encounter in our everyday lives. Prepare yourself for a journey through a universe filled with phenomena that redefine the boundaries of human understanding. From massive cosmic structures to distant giant worlds, and even a suspected parallel universe, these awe-inspiring marvels will forever change how you view the night sky. One of the most astonishing discoveries in the observable universe is the Hercules-Corona Borealis Great Wall. This structure, considered the largest and most massive in the cosmos, boasts an almost unimaginable size of 10 billion light-years. To put this into perspective, the diameter of our Milky Way galaxy measures approximately 170,000 to 200,000 light-years, making this cosmic behemoth tens of thousands of times larger. The term observable underscores the fact that our ability to study the universe is limited to what we can see from Earth. The universe, as far as we know, is homogeneous and isotropic, appearing the same regardless of the observer's vantage point. This creates a spherical boundary around Earth, marking the edge of our cosmic field of view, extending up to 46.6 billion light-years due to the ongoing expansion of the universe. Despite its apparent grandeur, the Hercules-Corona Borealis Great Wall's existence remains unconfirmed. Astronomers first identified it in 2013 based on an unusually high concentration of gamma-ray bursts originating from the direction of the Hercules and Corona Borealis constellations. This led to the hypothesis that the structure is a massive collection of supergalactic clusters forming a filament. If proven real, it would not only mark a groundbreaking discovery but also challenge our current cosmological models, which suggest that structures of this magnitude should not have formed so soon after the Big Bang. Such a revelation would necessitate a complete re-evaluation of how matter was distributed in the early universe. In our solar system, Jupiter reigns as the largest planet, with a diameter of nearly 140,000 kilometers. It's so massive that over 1,300 Earths could fit inside it. However, even Jupiter pales in comparison to the dimensions of exoplanet HD 100546b, located approximately 360 light-years from Earth. This distant world exceeds Jupiter's mass by a staggering 752 times and is still growing, surrounded by a circumplanetary disk that continues to accrete material. Discovered in 2014 through direct observation, HD 100546b is one of the few exoplanets to have been imaged directly. This planetary titan takes an astonishing 250 years to complete a single orbit around its host star. Its sheer size and ongoing formation offer valuable insights into planetary evolution and the processes that shape celestial giants in distant star systems. When compared to other stars, our Sun's immense size and mass seem relatively ordinary. Situated about 5,000 light-years away in the constellation of the Shield, UI Scooty dwarfs our Sun with a radius 1,700 times greater. If placed within UI Scooty's volume, nearly 5 billion suns could fit inside. This stellar giant is a variable star, meaning its brightness fluctuates over time, with a period of approximately 740 days. UI Scooty is in the late stages of its evolution, having left the main sequence millions of years ago. Despite its incredible size, it is not the most massive or luminous star known. Those titles belong to R136a1, a Wolf-Rayet star located within the R136 star cluster. With a mass 265 times that of the Sun and a brightness 10 million times greater, R136a1 also boasts a surface temperature exceeding 40,000 degrees Celsius. In comparison, the Sun's surface temperature is a relatively cool 5,500 degrees Celsius. Black holes are among the most mysterious and formidable entities in the universe. These cosmic omnivores possess gravitational forces so intense that nothing, not even light, can escape once it crosses the event horizon. While smaller black holes may form from collapsing stars, supermassive black holes, often found at the centers of galaxies, can reach unfathomable masses. The largest known black hole, TON 618, resides in a distant quasar in the constellation of Canes Venatici. With an estimated mass of 66 to 70 billion suns, this cosmic giant is a staggering example of the extremes found in the universe. Its associated quasar is one of the brightest objects ever observed, with a luminosity 140 trillion times that of the Sun. Such brightness is so overpowering that it obscures the galaxy hosting the black hole, making it invisible from Earth. Cosmology suggests that galaxy clusters should move randomly in all directions, but NASA's WMAP spacecraft revealed a perplexing phenomenon known as the dark flow. This discovery identified 1,400 galaxy clusters moving in a uniform direction, as if drawn by an immense gravitational force. The cause of this mysterious motion remains unknown, leading some scientists to speculate that it may be evidence of a parallel universe or an entirely different spacetime structure. Alexander Kashlinsky, the leader of the NASA team studying this phenomenon, emphasized that while the evidence is compelling, we lack sufficient information to determine its cause. Whether the dark flow is the result of another universe or something else entirely, it challenges our understanding of the cosmos and hints at a reality far beyond our current perception. The Tarantula Nebula, also known as 30 Doradus, holds the title of the largest known nebula and the most active star-forming region in our galactic neighborhood. Spanning 2,000 light-years across and located about 163,000 light-years from Earth, this celestial structure is a breathtaking spectacle of gas and dust. At its heart lies the R136 star cluster, home to some of the most massive and luminous stars ever discovered. Contrary to its ominous name, the Tarantula Nebula is a site of incredible beauty and serves as a natural laboratory for studying the processes that give rise to stars. Its vibrant hues and intricate structures remind us of the universe's capacity for both creation and destruction. While the universe is filled with countless stars, planets, and galaxies, some regions are defined by their emptiness. One such area is the CMB cold spot in the constellation Eridanus, a vast expanse significantly cooler than the surrounding cosmic microwave background radiation. This region is thought to be a supervoid, a colossal area spanning 1.8 billion light-years with far fewer galaxies than expected. The existence of such voids poses questions about the large-scale structure of the universe and the forces shaping it. Supervoids like the CMB cold spot are not merely empty spaces but critical elements of the cosmic web, influencing the distribution of matter and energy across the universe. Among the myriad galaxies scattered across the cosmos, IC 1101 stands out as the largest known galaxy. Located roughly 1 billion light-years away in the constellation Virgo, this giant elliptical galaxy spans an astonishing 5.5 million light-years. For comparison, the Milky Way is approximately 105,000 light-years across. Jupiter, the largest planet in our solar system, is already an impressive entity with a diameter of nearly 140,000 kilometers. The gas giant's mass is so immense that Earth could fit inside it over 1,300 times. Yet, when compared to some exoplanets, Jupiter seems modest. Take exoplanet HD 546b, for instance. Located about 360 light-years from Earth, this planetary behemoth surpasses Jupiter's mass by an astonishing 752 times. Discovered in 2014 via direct observation, this exoplanet is still accumulating mass through its surrounding circumplanetary disk and takes 250 years to complete one orbit around its host star. When it comes to stars, UI Scooty stands out as one of the most colossal ever discovered. Located 5,000 light-years away in the constellation of Scutum, UI Scooty's radius exceeds that of the Sun by a factor of 1,700. It could theoretically house nearly 5 billion suns within its volume. As a variable star, UI Scooty's brightness fluctuates over a period of 740 days. Despite its size, it is not the most massive star. That title belongs to R136a1, a Wolf-Rayet star with 265 solar masses and a surface temperature exceeding 40,000 degrees Celsius. When it comes to stars, UI Scooty stands out as one of the most colossal ever discovered. Located 5,000 light-years away in the constellation of Scutum, UI Scooty's radius exceeds that of the Sun by a factor of 1,700. It could theoretically house nearly 5 billion suns within its volume. As a variable star, UI Scooty's brightness fluctuates over a period of 740 days. Despite its size, it is not the most massive star. That title belongs to R136a1, a Wolf-Rayet star with 265 solar masses and a surface temperature exceeding 40,000 degrees Celsius. Thank you for exploring the cosmos with Space Lab. Subscribe for more incredible space discoveries, and let's keep reaching for the stars together. Stay curious.